So this is the first question. So according to the question, the term lost volts refers to the difference between the EMF and the terminal potential difference. Which of the following is an expression for the lost volts? So why the volt is lost? It is lost because of the internal resistance of the battery, which is indicated in small r. So let's write the equation. Total EMF of the battery should be equal to the potential difference across the simple R, let's say it's V1, and the voltage difference across capital R, which is V. So total EMF of the battery should be equal to the addition of V1 plus V. And this is given by epsilon. V1 is equals to the I simple R, because according to the Ohm's law we know V equals IR, and voltage across the capital R is I times capital R. So what is the lost voltage? As the question says, lost volt refers to the difference between the EMF and the terminal potential difference, so which is epsilon minus IR should be the lost volt, and it should be equal to the I simple R. So the answer should be B. This is the second question. Second question. Kinetic energy can be written as half times mass times V squared. The student in the question measures mass in grams and velocity in kilometers per hour. However, the question asks which of the following should the student multiply the answer by to obtain an answer in joules. So when the question asks for joules, we need everything to be in SI units, because in SI units energy is in joules, mass is in kilograms, and velocity is in meters per second. So we need to convert the none in SI units into SI units. So how are we going to do this? We know mass. For mass, we need to convert grams into kilograms. So we need to divide mass by 1000 in order to convert grams into kilograms. And for the velocity, we need to convert kilometers per hour into meters per second. So how are we going to do this? Velocity, we need to multiply kilometers by 1000 to convert into meters, and hours to convert into second, we have to multiply by 3600. And now if we substitute everything into the energy equation, we'll get half m over 1000 v times 1000 over 3600 squared. Now if we simplify the factors, we can write as I'm going to write V first and then the factors. 1000 squared, 3600 squared, and we can simply cancel off 1000 with the 1000 in on a top. Therefore, so this was the initial calculation by the student. So we need to multiply the initial calculation calculation by a factor of 1000 over 3600 squared in order to represent the answer in joules. So the answer should be A. So this is the third question. A ball is dropped vertically onto a horizontal surface and bounces twice before being caught. The graph shows how the velocity of the ball varies with time for the motion of the ball. So we have to pick what is the correct acceleration time graph for this motion of the ball. So let's try to plot what would be the acceleration time graph for this velocity time plot. So whenever a ball is in the air, the acceleration acts on it is the gravitational acceleration that we know. Acceleration, which is denoted by g and which has a value of 9.81 meters per square second. So whenever the ball is in the air, this is the acceleration acts on the ball. Therefore, these three lines represent the gravitational acceleration because these are negative gradients. That means negative acceleration, which correspond to the gravitational acceleration. Gravitational acceleration. So why this is negative? We consider the upward direction as positive and downward direction as negative. So because the gravitational acceleration acts in the negative direction, this is a negative gradient, and we denote that as in a negative gradient. So we can plot this in the acceleration time graph as negative value. This is a constant. And what correspond to these positive gradients? So these are positive gradients, which means a positive acceleration. So when the ball hits the surface, so when the ball is dropped, there is a time where it hits the surface. So at the moment it hits the surface, the downward acting velocity turns into the positive direction velocity. It quickly changes its velocity within a very short time. Therefore, it results a positive acceleration in upward direction. That's why we can see these two positive gradient lines in the graph. Therefore, we can plot that in the positive direction. So we'll get a graph like this. This is the fourth question. A potential difference V is applied across the ends of a conductor. The drift velocity of the charge carriers in the conductor is simple V. Which of the following expressions give the relationship between drift velocity and potential? Fourth question. For a conductor which has a cross-sectional area of A with a charge carrier density N, and suppose for each charge the charge of the carrier is Q, and the drift velocity of these charge carriers are simple V. Therefore, we can write the electric current flows in this conductor using the transport equation, which is NQVA. And from the Ohm's law, we know V equals IR. This is the potential difference equals current times resistance. So we can substitute for I using potential difference. So potential difference, capital V, over resistance can be given as NQA times drift velocity. Therefore, we can have the relationship between the potential difference and the drift velocity as V is directly proportional to the drift velocity. So the answer should be C. This is the fifth question. So the fifth question, initially the plane is traveling towards north at a speed of 42 meters per second and the wind is blowing from east at a speed of 7.5 meters per second. So in order to keep the plane moving towards north, a plane needs to turn towards east at an angle of theta from north. So we need to find out what is this theta. So if we draw the vector diagram for the plane, so the wind is blowing at a speed of 7.5 meters per second and plane is moving at an angle of theta from north at a speed of 42 meters per second. Therefore, in order to keep the plane moving towards north, the resultant force should be, or the resultant velocity should be in north. Therefore, we need to find out what is this theta. Therefore, we can write sine theta is 7.5 divided by 42. Therefore, theta is sine inverse 7.5 divided by 42. Therefore, the answer is B. This is the sixth question. An ohm meter was used to measure the resistance R of a length L of nichrome wire as shown. This was then repeated for different values of L. The diameter of the wire was measured and the cross-sectional area A of the wire calculated. So the diameter was measured and the cross-sectional area A is calculated. A graph was plotted. The gradient of the graph was equal to the resistivity of nichrome. Which of the tables shows the quantities which were plotted on the y-axis and x-axis? So let's write the equation where we can relate the resistance of a wire to the resistivity. We know this equation, resistance is equal to the resistivity times length of the conductor over the area or the cross-sectional area of the wire. Therefore, we can rearrange this equation such as RA equals rho L. And according to the question, they say the gradient is the resistivity. So if we rearrange as in y equals mx equation, so the x-axis is length where y-axis is RA. Therefore, the answer is D. So this is the seventh question. A meter ruler was used to measure length. The following measurements were collected. Length 1, 89.1 centimeters. Length 2, 89.6 centimeters. Length 3, 89.4 centimeters. Which of the following is the most appropriate uncertainty to use for the length of the piece of wire? So in example like this, we can give the uncertainty as range divided by 2. So the range of this measurements can be written as the maximum value minus the minimum value. So the maximum is 89.6, minimum is 89.1 divided by 2. So we'll get 0.5 divided by 2, and this is plus or minus. So we get plus or minus 0.25. So if we round up, this is the closest answer. So the answer is answer. Question 8. A rope is used to pull a box a distance d along a horizontal surface at a constant speed. A force F is applied to the rope and the rope is at an angle theta to the horizontal. Which of the following could be used to determine the work done on the box? So we can write work done is force times the distance, and this force and distance should be in the same direction, and the question says the direction of the motion is this way and the distance displaced along this direction d. Therefore, we have to find the force acting on the direction of motion. So we have to decompose F in this horizontal direction. So we get F cos theta. Therefore, we can have F cos theta times D. So the work done should be FD cos theta, and the answer should be answer B.